Hello and welcome to my video. As you probably could tell from the title of the video, we're going to be exploiting an SQL injection vulnerability on an Azure Function app. And a little bit of a kind of warning, this does involve a little bit of web hacking. And so we're going to be using both and things like that. But let's get into it. So let me tell you the scenario first and foremost. Our red team performed a password spray and compromised several accounts that had been recently created with a default password ready for the new company hires to log in. You have been provided with credentials. Long story short, we got some creds and let's get hacking. So for this, we're going to be using the standard setup, Kali Linux and PowerShell. All right, so let me open up a new PowerShell. And the reason why I use PowerShell instead of on Kali here on my Windows host is because it's more integrated and there are less problems and it's more convenient. All right, so let's go ahead and grab the credentials and just authenticate in the standard ways that you authenticate to any Azure account. First, I'm going to go ahead and use AZ login. Okay, no problems. Connect AZ account. And as you can see, we have no MFA problem. If you want to see how to get around MFA or what the protocols are for that, take a look at most of the other Azure videos where we do have an MFA problem. And so now that we're here, let's go ahead and take a look at the resources that we have available to us. All right, so looks like we got another website. And this is great because from here, we can do a bunch of things. However, before we move forward in trying to enumerate this, let's see if we can take a look at the roles that are involved, the roles that this user has access into seeing. Okay, so as you can see, Buddy has this role called website contributor. So just associating that with the resource that we found, the attack path is most likely about this website. However, we do also see these two roles. Now, if you're taking a CTF approach, this is always crucially valuable information for future attack paths of different labs. However, now that we know that we have a website at hand, let's go ahead and enumerate that and take a look at this website. So here what I did was check if this website has a managed identity. Now this is crucial because if it does, and we're able to get in any way like an SSRF, which is common for these cloud websites or anything of the sort, we now know that we can impersonate it as an account and access resources to move laterally through this website. All right. So now that we know that, let's go ahead and access the website. So to access this website, we need to figure out what the host name is. So I'm just going to use this command for general info about it. And if we just scroll over here, as you can see, here is the website name. So let's grab that. Keeping burp open, we can go to the associated Chromium instance of it, or Firefox if that's how you set it up, and close these things and go to the website. All right, great. So we can see that this website is up and running. And one thing that we learned in previous labs is that these websites hosted on Azure always have a default admin portal, admin location, which utilizes the framework called Kudu in order to manage and use the web server behind this website. And so in order to get there, we just add an SCM right in between the custom name and the default portion of the website. So you add it right here in the middle. All right, so let's sign into our user. Might be a different user that we're signed into right at the moment. All right, so where's Buddy? There we got Buddy, our compromised user. Enter his creds. And since we have the contributor role for this website, then we are able to manage it with Kudu. Isn't that beautiful? Now, if you did this in a CTF approach, this would be a glorifying moment. However, once we're here, to explain very briefly, Kudu has a lot of managerial functions for your website. And one of those is, as you could probably tell right here, debug console, which provides us with console access of the web server behind this website. So just like any Azure instance or virtual machine or whatever you want to call it, all of these things have the potential to have a managed identity. And since we checked that, yes, in fact, this has a managed identity, we can go ahead and access the MSI endpoint in order to retrieve the token of the management identity. And so firstly, if you just want to confirm, although the variables are largely default in these situations, let's go ahead and check the environment variables. And I apologize if it's very small. Let me go ahead and make it big. All right. Okay. So here we have the variables. So let's scroll up a bit to the MSI information. Okay, so as you can see, here we have the default variables of identity endpoint, and this, oops, let me scroll back up. So on these websites, on your Kudu, you can just quickly search identity after you output the variables, and you'll go straight to the variables that we're trying to look at. And so over here, you're probably wondering if this variable, is default, then why do we even need to check the environment variables? Well, the environment variable name is default, but the value of it is going to differ due to the fact that they randomized the port number in order to evade things like SSRFs. And not only that, but the identity header, which the value of that is a secret, is also going to be randomized. Now, there are still ways around this if you're trying to perform an SSRF. However, you will need to somehow attain this information, this specific secret string, in order to succeed in the SSRF. However, this port number can be brute forced. All right, so with this in mind, now we have the variables that we need and their values in order to access the token. So let's go ahead and retrieve that. Okay, awesome. We got the token. So let me explain the commands that we used. Firstly, we specified the URI from the variable, which includes the randomized port. And in that, we specified the API version, which is also required because if you're not using the version that allows this execution to occur, then you will be denied. And then we get the token through making the request using the headers and the URI. The headers as well included the secret that we found in the variables. And with that, we get this service principals access token. So let's go ahead and copy that into our PowerShell. All right, nice. Now, once we set this variable in here, let's go ahead and connect to the service principal through that. And before we do that, since we do need the service principal's identification ID, then object ID, then let's go ahead and do that through the current compromised user. Let's get that ID in order to connect to this account. And as you can see here, we get this principal ID, which we need in order to authenticate to that principal, because instead of including the email, since we're using a service principal, we're going to include the principal ID of it. And now connecting through the connect-az account option command, we're going to specify the token and crucially the account ID being the principal ID, and then the tenant ID, which stays the same across all these accounts. So now that we're here, we can go ahead and see what resources we have access to. And although we have a bunch of errors and stuff, I'm not sure if that's a part of the lab or if that's a serious problem, but I'll make sure to talk to the lab instructor about that. But anyways, we can scroll up here to the significant finding, which is the MBT subscriptions website. All right, we got another website. So let's go ahead and check that out and get some information about it to see maybe it has another host name. Maybe we can attack it as well. Let's see what we can do with it. So using the command to get the AZ websites that we have access to, we see over here in the details of the website, MBT subscriptions, that it is the kind of function app. So now that we know that it's a function app, let's go get the information of this function app through the get function app command. Get AZ function app, specifying the resource group and the resource as always. We can then see some information about this function app. Now, in a function app, as you could probably assume, it includes different functions, and these functions are like accessible endpoints that do things to kind of make operations happen or automate things, etc. And so let's go ahead and get these functions. Using this command, we are able to get the properties, which include the functions of the function app. And so as you can see here, the function is called HTTP trigger 1, and it has a bunch of other files in its environment. And the function itself, I believe, is in JSON, as you can see by this extension. And the way to invoke it is to access this URL. And so let's go ahead into our burp Chromium and try to access this function. And as you can see, it says to access, let me go ahead and make this bigger. To access the subscribers database, please provide an email address to return details on a subscriber. Example, Mason Lopez at lycos.com. All right, so now that we have successfully invoked this function, this is a huge point of our lab training lab engagement, because this means that we're going to start attacking it. Now, as per standard protocol for finding functions on a website or a parameter or any of these sorts of endpoint related attacks, we need to start discovery. And so discovery in this case revolves firstly around finding a parameter. Now, I know that already by the description that you see on the screen, you could probably gather that the parameter is called email. However, in these labs, I'm trying to teach you how to use repeatable methodology. And because of that, I want to show you how to get this parameter through FUF and through fuzzing. All right, so if you try to use FUF standard-like, you won't succeed on Azure infrastructure. And this is because the headers are required. Some of the headers are required for FUF to work. And so because of that, the methodology that you should do in order to make a FUF command is to retrieve the headers from a normal request on burp and then transform that into a FUF command using something very convenient like ChatGPT. And so let's go ahead and do that. Over here, if I open up my burp and I go to proxy, I can take a look at the history section and see the HTTP trigger had this specific request. And we have these headers. So if I go ahead and take this and I copy it into ChatGPT and I tell it to make me a FUF command using the specific word list that I want, depending on how big that word list you want to be or how many noise you're allowed to make, you can specify the jitter, you can specify the delays. And after doing all that, long story short, I get this command. And let me go ahead and explain it to you. Here I am using the burp parameter names word list, quite standard for finding parameters. The post request as per the invocation of the function. And then I'm going to specify the URL and the host. And here I specify the user agent. Now, slightly unrelated, but over here, you have a little bit of potential to manipulate the things that potentially it is using conditional access policies against. And critically over here, this header, which is the accept header, is not your standard JSON application header. And that's simply because that's just not the header that that's just not the accept that it has. And so you need to use this one. I recommend you keep it somewhere and test it out if you ever get into an environment like this in the future. Test out all the headers that work, and a nice way to figure out which accept header works, which value for that works, is if you make a simple curl command in order to see that. And so let me do that for you. Okay, so I have the curl command here. And if we use this, it works very simply. It works easily without any headers. And I believe that's because curl has some kind of default method of just using the things that it wants. But If we want to see why this worked after experimenting and finding that our own commands on FUF or whatever tools you're using doesn't work, the protocol in order to make your tools work when they don't is to pipe them, or rather proxy them through Burp Suite in order to see the specific requests that are being made. And so I did that here by creating an environment and then using the curl command. So let me show you from scratch how to set up the proxy through Burp for curl in order for us to see what's going on and why it works on curl and why not on a tool like FUF. And so I made a little list here that shows all of the commands step by step. So firstly, we're going to make an environment. And then we're going to enter that by specifying the source of the environment that we made. And then we're going to install certify, import certify, Now, in this step, we're going to need to download the Burp Suite certificate and then move it to our current directory. And so in order to do that, we need to use the Chrome tab and go to Burp Suite and click here, CA certificate. Now that we have that, we can rerun this command to move it to our current directory. And now we convert the Burp CA certificate to a PEM format. And next we copy the Burp certificates to System Trust Store. And now we append the Burp certificate to Python's Trusted CA bundle. All right, and now we can use our curl command. So where is the curl command that I was using? Go ahead and see if it catches this time. So including the proxy flag and including the proxy of Burp, which is by default 8080 on your local host, and the CA cert that we created, cacert.pem, that we set up, now we're able to make curl requests. Now we're able to use this command and it will all be proxied through Burp Suite. And so as you can see, now we can see the working Burp request and we know which headers we need and what things we need. And so in the specific scenario, the key factor that makes this work is this header called content type, and it's going to be required that it's application xwww form URL encoded. Now, once we have this information, we can create the correct FUF command in order to fuzz for the parameters. You can pause and take a deeper look at all the specific things that I put in this command, but really I just asked GPT to make it for me, and then I edited it after checking Burp Suite to see why it's not working in order to include this correct accept header. And with that, as you can see, we get a lot of false positives at first. And after seeing that, We just specify to filter out whatever is common amongst them, which in this case is the size 131. Now, if it's being like this in the terminal and giving you all the progress in every single line, you can just zoom out. And as you can see, we find that correct email parameter called email. All right, so with that being said, at this point, although we already know that we're supposed to include an email, I just want to mention that we can also create custom parameter value word lists in order to suit the parameter attacking situation at hand. And this is crucial in other scenarios, but in this case, obviously we know that we need an email, not just by the description, but here by the parameter called email as well. And so now with that information, let's go ahead and try out an email as the value with the parameter that we know. And over here, I have the request in my repeater. And as you can see, we get information from the SQL database. Mason Lopez. All right, so since we are dealing with a database, and since it is an Azure host that we know is running, now let's start some SQL injection attacks. And so before we start to do any manual attacks, I want to show you how to automate this because automation is key, especially in the most preferred assessment style of penetration testing. You're not going to be really worrying about the amount of noise that you make as much as the amount of vulnerabilities that you find. And so automation is always crucial to grasp no matter what lab you're doing. Even in this case where the lab guide tells you to use these manual things in order to succeed in the lab, I want you to always have this approach where in real life, depending on the different scenarios at hand, what do I actually need from this lab? What do I need to learn in order to apply that there? And that's why things like automation, documentation, multiple things that, the lab guide doesn't tell you to do, you have to try to learn those. And if it's not in the lab guide, believe me, things like Google and ChatGPT can tell you how to do it. All right, so let's go ahead and use a simple word list in order to check for injections. So if we send this to to intruder by going right click and send to intruder, we can go to intruder. Wait, and send it. Okay, so now that we are here, we can go ahead and specify the position of the payload. And then we can load an SQL injection word list. Now I'm showing you how to do this on Burp Suite. There it is, SQLi. And huge SQL.txt is found through this location. Let me go ahead and grab it for you. But essentially, as you can see, this includes a huge list of potential injections. Now, I have not done this on Burp Suite because I don't have Burp Pro. But if you have Burp Pro, then this is viable. However, if you don't, they limit the time of the request, or they limit the speed at which you can make requests. But let me quickly show you where you get this word list from. All right, and so as you can see here, by the user pen testicle, we have this SQLi word list called huge SQLi.txt. And so you can grab this. I did not find one on sec lists, so might be valuable for you. All right, and now that we have this, all we simply do is press start attack. But unfortunately, since I'm not paying for burp, I believe it's $500 per year, then it is very slow. However, since we did get a working theft command through seeing what works, now we are going to use fluff. And paste this command and explain it for you. So here we're specifying the word list, huge SQL.text, using the absolute path so we can always copy paste it in the future. And then we just use the same fluff command that we used in order to find the parameters, except for we are fuzzing for the value here instead of the parameter. And let me go ahead and change that parameter name to email. And before we filter, I just want to demonstrate how you find how to filter. As you can see, we find a lot of false positives again, but there is a bunch of zeros here indicating that the response size equals 0, indicating that the response is 0. And so from there, we just add the filter size command of 0 in order to remove that. And then we zoom out in order to stop the clutter. All right, and now we see two sort of sizes here, 131 and 55125. Now, obviously, we're going to be looking at the bigger size. And as you can see here, here's one of the injections that are found, although it found many. Let's go ahead and grab that and plug that into our repeater to see what is going on with that response. All right, so we get a lot of stuff. We get information on all the users. Awesome. So now that we have a working SQLi injection, what we want to do is a two-step framework for finding the table name. And this is demonstrated through the lab guide scripts that I am going to use. Now, of course, you can use other methods. In fact, I believe professional and advanced web application hackers you make their own POC scripts and their own things in Python of that sort, depending on the environment that they're working with, in order to automate these sorts of attacks. This is because what we're going to be doing is a time-based attack in order to first find the table length and then find the name of the table. So I'm going to here copy the script that the lab instructor made for us. Let's go over here, and we're going to say table length finder.sh, and I'm going to paste the script. And so as you can see here, it uses the time in order to check if the time is great enough. If there's a great enough of a delay, then that means we found the successful character or value that we're looking for. And we keep repeating this process until we find the full table length, and we do it again for checking the whole alphabet for each position in the length that we find in order to find the table name. Let's go ahead and use this. So it goes ahead and checks, basing its findings off the delay. and we find the table name length of 7. And now that we have this table length, let's go ahead and find the table name using another script that the lab instructor made. As you can see, it's going to now check all the alphabet for each position, making sure to only stop and give you a successful letter if there is a great enough delay in the response. Now, this is in fact the end of the lab. After you find this table name, you insert that as the flag and you have successfully completed the lab. However, there's a lot to take away here, and it's always great for you to experiment, especially in this situation where the web attack depends on the framework that we're using and the environment being Azure. There are a lot of significant details that make your tools work and that you should learn through experimenting. And so I urge you to delve into this lab a little bit more, experimenting with whichever methodology you have currently for web attacking or for Azure, and trying to transform that in a way that also involves this scenario and similar scenarios like this in the future. All right, so we get the table name here, MBT SBCN, and you can plug this into the input field for the flag, and you will successfully complete the flag. So thank you very much for watching. I hope you enjoyed. And if you enjoyed, please let me know in the comments below what kind of any cloud service provider penetration testing methodologies or techniques you want to see in the future, or things that you haven't done research on and you want to see a video on. Anything like that. And if you like, please like and subscribe and follow my Twitch. And thank you for that. And goodbye.